The 2017 Nobel Prize for Physics has been awarded once again to mathematicians. This time it's for decisive contributions to the LIGO detector and the observation of gravitational waves. It seems the inmates are in charge of the asylum. Last month at the Royal Institution, Dr. Jim Baggott, an award-winning science author, lectured on the concept of mass, which is essential for understanding gravity. He declared that theoretical physicists have a dirty little secret. He explained, "The mission of a theoretical physicist trying to work out the nature of substance and elementary particles is to get the maths to work out correctly and consistent with what's gone on before. So we're discussing mathematics, not physics. And of course, what's gone on before is that mathematicians raised Einstein's general relativity to the status of scripture, while that theory ignores the substance of stars and planets that exhibit mass and gravity. So the theory has no physical basis whatsoever. It depends instead on a warped view of reality." Unsurprisingly, Jim Baggott failed to physically define mass or explain the mysterious equivalence of inertial mass and gravitational mass.
Right. So basically what he's saying here is, you look at the E equals MC hammer equation. E equals MC squared equation. I had to use that, John. I love that from last week. But they're saying that, okay, we have energy equals mass times the speed of light squared, right? E equals mc squared. Well, they have never been able to adequately define what mass actually is. And this is no secret, guys. That is what is truly astounding about this. This big theory, this big formula that Einstein has come up with is simply based on pure and absolute mathematical conjecture. And in fact, you got to love this little chart right here, that shows the difference between science and math. And science and math are not the same thing. Physics and math are not the same thing. Math is a tool used to describe things in physics, but absolutely what they're doing today is they're wandering off, like Tesla said, they're wandering off through equation after equation. We're at the point where everything is a mathematical construct and it has absolutely no basis in observable reality. Okay, so here's the comparison. Science says to make observations. Math says to make assumptions. Absolutely true. Collect data and look for patterns in science. Collect data and look for patterns in math. Okay, we got a match there. Science says to state a hypothesis. Math says state the conjectures. Science says construct a theory. Math says prove the theorems. Okay, and then here's the big difference. Science says gain a better understanding of our universe, meaning the real universe, meaning the one that we actually live in, right? And math says gain a better understanding of a universe, and that a universe is the mathematically constructed universe. Okay, not anything in reality, but something that was simply dreamed up by mathematicians. And of course, they can always make their numbers fit. And like Wall just said, the job of the mathematicians is to make it fit with previous observations and to make it work out with their overall theorem. So let's continue.
The dirty little secret is that mathematics is the foreign language of physics. Few claim to understand the language, and the Math to English dictionary is woefully incomplete because the editors, the natural philosophers, were sacked a century ago. So key words like mass and energy are physically undefined, and infinities are reified, which allows a photon to exist having no mass but carrying energy. The shocking truth is that...
Okay, so I want to accentuate what he just said. Infinities are reified, meaning that in the mathematical world, the only way that they can make these mathematical models work is to introduce the idea of infinities, right? Infinite gravity, infinite mass, infinite this. Well, anybody with any common sense at all knows that just by making the statement of infinite gravity means that if that is true from any one point in space and it's infinite, that everything is sucked instantly into a black hole and nothing else could possibly exist. We couldn't exist. And again, this is a mathematical construct. Is it real? Obviously not. I mean, it's nonsense. So that's I just wanted to accentuate that. Infinities are commonplace in mathematics, but not in the real world. And in fact, in the real world, we have no example of infinity. Period. End of story. Let's continue.
Well, and another good point that he made is that all of relativity is based, or well, maybe not relativity, but the idea that photons or protons, whatever he said, can have energy but have no mass, and that is a bit of a conundrum, isn't it?
Yeah, just a little bit.
Yeah, just a little bit.
Yep. So.
The only infinite thing is the budget of NASA. That is infinite.
Right. Okay, let's continue.
E equals mc squared is not physically understood. It seems physics is a foreign discipline for mathematicians also. Phys.org asks, what is space-time? And answers, space-time is the mind-bending, four-dimensional way astronomers see the universe. It melds the one-way march of time with the more familiar three dimensions of space. But how can astronomers see anything in four dimensions? And point me in the direction that time is marching. Lumping together the concept of locations in three dimensions, that is space, with the numbers on clocks, that is time, cannot constitute a physical fabric. Space-time is a meaningless concatenation of words. It isn't physics. As a result, translations of theoretical mathematics into plain English have become meaningless, New Age nonsense.
Absolutely. Because we get these times. I mean, first of all, everybody knows that a clock is not representative of time. Time is a man-made concept, okay? And space, we have Einstein's definition of space as basically something that is malleable and can be bent with mass, which is again another undefined mathematical construct. So again, we're just building fantasy after fantasy after fantasy, with these mathematical equations, and it has no basis in reality whatsoever. And this goes back to, the whole thing about LIGO, about these gravitational waves. The way that LIGO supposedly works is when these gravitational waves actually cut across these 8-kilometer long tubes, it physically alters the size, the length of these chambers, right? We have no example of that. Nowhere. No experiment, no empirical evidence, nothing. So where are they even coming up with the idea that this is even a viable way to test for gravitational waves? And the other thing that's really amazing about this is because they're wanting to sense just very, very small changes in physical structure. Isn't it interesting that the LIGO detector that is built in Louisiana is built right on the intersection of basically 3 fault lines? No room for any misreadings there, right? Sheesh. Okay.
I liked what was it? Physics.org definition of space-time. It was pretty much just a bunch of words.
Yeah, nonsense, just like Walt said. So let's continue on.
Mathematics isn't physics. When it comes to experiment, how can our prize winners claim an infinitesimal signal is a hypothetical gravitational effect allegedly caused by objects, black holes, that have never been observed? How can our prize winners be so specific about the masses of 2 merging black holes? A black hole has never been observed. If a theorist is unable to discover real objects, which cause the observed effects, it is unscientific. Indeed, it is fraudulent to invent unreal objects and present them as a factual discovery of the cause of those effects. Gravitational waves and black holes are merely mathematical speculations with fatal problems, which I'll address in a moment. And how can you have decisive contributions from a detector when the effect is a displacement of less than the width of a proton over 4 kilometers?
Right, and that's another thing you got to remember. Over 4 kilometers, and we're talking about these lasers are picking up something that would be less than the width of a proton, right, over that distance. Can you even imagine that type of scale? I mean, anything would cause, even a vibration in the earth.
A gnat farted.
Yeah, I was going to actually say that. If a fly farted, it would absolutely set that thing off. It is so preposterous, it's unbelievable. But and that's his point here, so let's move on.
The experiment is a textbook example of pathological science,
Amen.
matching signal patterns from a huge database of 250,000 theoretical templates of alleged binary black hole collisions, hoping one might coincide with the infinitesimal recorded signals. Critical to the detection algorithm is that the alleged gravitational waves are assumed to travel at the speed of light. So there is a time delay expected between similar signal patterns from separate LIGO detectors. But Newton's theory, which is used successfully to navigate the solar system, has gravity operating instantly. Time doesn't appear in his law of gravity. Newton's gravity acts like a rigid rod between celestial bodies, where the tug at one end is felt immediately at the other end.
Does that sound familiar, Jaron? Didn't you make a video on that?
Absolutely.
and that would be exact.
Getting the big thing that math is reality. Okay.
Yeah,
Don't get
yeah. You got to remember that.
No, you said it wrong. It's math is reality. No.
math is reality. Sorry.
So yeah. So again, now what he's going to describe here is the stark contrast of the two gravitational theories between Newton and Einstein. And isn't it amazing how physics will just kind of go back and forth and back and forth? And the other thing I forgot to point out a minute ago is, isn't it amazing that the Nobel Prize for Physics went to mathematicians? Hello, the mathematicians are not physicists, and basically math has very little to do with the observation and mechanics of, a physical universe. So that in and of itself is preposterous. But let's move on.
This is actually essential for the clockwork regularity of the planetary system, but it's never considered because the effect exceeds Einstein's speed limit of light waves. What light has to do with the force of gravity is not explained. Meanwhile, the phys.org report states, gravitational waves stretch space in one direction and compress it in a transverse direction. How Einstein's gravity, which does away with force, manages to allegedly stretch and compress a four-dimensional geometric concept of empty space is unexplained. The important thing to note is that the signals did not arrive at the same time in each LIGO detector, so the LIGO signals were not caused by gravity. More damning, though, is that the physical implications of black hole theory seem not to be understood by any academic. Steve Crothers addressed this issue in his Electric Universe 2017 presentation. Amongst other things, he points out that the black hole universe is infinite and not expanding, while the Big Bang universe is finite and expanding. The black hole universe is eternal, while the Big Bang universe is 13.8 billion years old.
So, and listen up to this close, guys, because look at this chart, versus, the black hole universe versus the Big Bang universe, and, the main differences in the two. And as you can see, they are in absolute stark contrast to each other. And, again, there's a whole lot of assumptions with infinities and all this stuff. And Steve's going to go over this and talk, or actually, Steve did cover this, and I've got this EU talk. It's fantastic, but let's continue on.
The black hole universe is asymptotically flat, while the Big Bang universe is not asymptotically anything. A black hole universe contains only one mass, while the Big Bang universe contains many masses. So we, as observers, cannot exist in a black hole universe. And two black holes orbiting each other in the Big Bang universe is impossible. Yet we are led to believe that 4 binary pairs of black holes have been positively identified and accurately weighed through vanishingly tiny chirp signals. To drive home the sheer nonsense of black hole theory, Steve itemizes its properties. A black hole has finite mass concentrated at its singularity. The singularity has 0 volume and infinite density. The black hole has no gravitational force, only space-time curvature. There is infinite curvature at the singularity, which means infinite gravity. Steve says, let's think about that. A finite mass is located in 0 volume. It has infinite density. It has infinite gravity. Do you think any such thing exists? It's simply assumed by the originators of black hole gravitational collapse theory that matter is uncharged and infinitely compressible. It is also simply assumed that the gravitational equations and the universal constant of gravitation g, are universal and can be applied inside the Earth and stars without change. There is no mention of the matter in those bodies, which is the origin of their mass and gravity. Meanwhile, their partners in mathematical fraud, particle theorists, have decided that normal matter has no intrinsic mass, which further obscures the origin of gravity and our understanding of the universe. It's a self-serving myth that Einstein's mathematics predicts black holes. The originators of black hole theory in 1965, including Thorne, chose not to mention that Einstein's October 1939 paper, which they refer to, concludes with, "The Schwarzschild singularity," the term black hole had not been introduced then, "does not appear for the reason that matter cannot be concentrated arbitrarily, and this is due to the fact that otherwise the constituting particles would reach the velocity of light." Einstein showed mathematically that black holes cannot form gravitationally for the same reason that stars and planets cannot, because the infalling matter begins to circle the centre of mass until the centrifugal force balances the gravitational force. The observational evidence now shows that stars and planets are formed by the powerful electromagnetic force produced in electromagnetic pinches along cosmic lightning filaments in molecular clouds. Gravitational collapse theory is now discredited by direct observation.
All right. So that is absolutely astounding what he just said. And again, we have these different models of the universe, and it's simply, they are simply incompatible with each other. And yet, whenever they want to roll out some theory, to try and reinforce Einstein's theories, they are rolling out something that is in stark contrast to his own mathematics, his own theorems that he has put out. And it's absolutely astounding that anybody, again, who follows this doesn't get this. It is so simple. Einstein debunks himself time after time after time again, and NASA debunks Einstein by their use of Newtonian physics, out in the solar system, right? So again, here we have two different models, and they are used, at the convenience of whoever's putting together the mathematical theorem to describe their model. Is any of it backed by any observational evidence whatsoever? Absolutely not. Mathematics, in terms of describing the universe, is a fraud, plain and simple. And I don't know what other conclusion anybody can draw from this. And this is exactly why they're rolling out, then stepping up the propaganda behind NASA and their discoveries and more CGI. They're literally flooding the minds of people, and they're absolutely making up blatant lies when they can't even define what mass is. There is no actual technical definition for what mass is, and yet we have this gravitational model of Einstein's, which is basically described by bending space fabric itself, space-time itself, versus the Newtonian model, which comes to us by masses attracting in on themselves and creating gravity that way. It's just beyond belief.
The first point that we need to note is that theory was mathematically correct within the existing observational limits, the then existing limits. That is a general characteristic of all inventive theories because they are invented for that specific purpose. They are specifically designed to fit mathematics that are already known. And I'm stressing it at this time because it will be important later on in other connections. If the information is available, if all the essential information is there, then there's no need to invent a theory. Then we can obtain it by inductive means. if the essential information is not there, then any theory we invent cannot be conceptually right. This new science of Newton and his contemporaries was a vastly improved product, and it scored some very impressive successes. At one time, the practitioners of that science were pretty thoroughly convinced that a knowledge of the entire physical universe was within their grasp. But here again, the inherent weakness of an inductive theory again asserted itself, and Newtonian science found itself faced with a series of problems for which it had no answers. So then the present-day inventive science took over. Now, when an idea or a set of ideas gains general acceptance and becomes a familiar feature of thought, its origins recede from view. And I wouldn't be surprised but what many of you may be reluctant to accept the idea that the basic theories of present-day physics, such as the relativity theory, for example, belong in the same category as the Ptolemaic theory of planetary orbits. But they were all inventive theories. The originators of the present-day theories don't deny that. In fact, they emphasize it. We might even say they glory in it. Einstein told us that pure invention is the only way by which these basic principles can be obtained. And he was highly critical of Newton's attempt to ascertain them inductively. Here's what he said. Newton believed that the basic concepts and laws of his system could be derived from experience. The tremendous practical successes of his doctrines may well have prevented him and the physicists of the 18th and 19th centuries from recognizing the fictitious character of the foundations of his system. Einstein's own view was that the basic concepts and laws of physics, what I'm calling the fundamentals, are, quote, in a logical sense, free inventions of the human mind. He elaborates this view in these statements that I have taken from his book, The World as I See It. Since, however, space perception only gives information of this external world of physical reality indirectly, we can only grasp the latter by speculative means. The theoretical scientist is compelled in an increasing degree to be guided by purely mathematical, formal considerations in his search for a theory, because the physical experience of the experimenter cannot lift him into the regions of highest abstraction. The axiomatic basis of theoretical physics cannot be an inference from experience, but must be free invention. There is a rather general tendency to believe that Einstein and the other architects of modern physics could not have been as casual about the foundations of their system as these words would indicate, that they must have been tied into something, anchored to something solid somewhere. But that's not true. As Rudolf Carnap puts it, they were constructed floating in the air, so to speak. Einstein gives us enough information about the origin of his own theories to make it clear that when he talks about free inventions, he means free inventions, nothing else. For instance, the propagation of electromagnetic radiation plays a very significant part in his theories. And the comments that he made about the theory that he invented to account for that propagation have a considerable bearing on what we're talking about now. In one of his books, he goes on at considerable length about what a difficult problem this is. And he concludes with this statement: our only way out seems to be to take for granted the fact that space has the physical property of transmitting electromagnetic waves, and not to bother too much about the meaning of this statement. That space has the physical property of transmitting electromagnetic waves, and not to bother too much about the meaning of this statement. The point of all this is that all invented theories share this same defect. They are all mathematically correct, but they are all conceptually wrong, not because of any errors in the construction, but because of their inherent characteristics. Now, this statement may seem to be in direct conflict with a great many of the confident assertions that we find in present-day scientific literature, which tell us that the validity of present-day theories has been established beyond any reasonable doubt. But if you look at the evidence in support of those assertions, you will find that it is all mathematical. What has been done is to establish that those theories are mathematically correct, just as I have said here all along that they are, because of the way they were constructed. But those theories that are mathematically correct are not unique. None of them is. In every case, there are other theories that are also mathematically correct. And as Richard Feynman tells us, we can't distinguish between any two of them on any scientific basis and say which is correct. Because, as Feynman says, they both agree with experiment to the same extent. So two theories, although they may have deeply different ideas behind them, may be mathematically identical, and then there is no scientific way to distinguish them. Now, Feynman goes on to say this: every theoretical physicist who is any good knows 6 or 7 theoretical representations for exactly the same kind of physics. What Feynman does not say is that those statements apply only to the present day and other day inventive theories. They do not apply to inductive theories. That is, theories that have been derived by induction from factual premises. For example, the kinetic theory of gases is a theory that relates the gas laws to the motions of the particles that compose the gas. Now, no one tells us that he has a half a dozen equally valid representations for what the kinetic theory tells us. In fact, there's not another one alternative, because the kinetic theory is an inductive theory that's tied into the facts both mathematically and physically, so that it's both conceptually and mathematically correct, whereas the inventive theories are correct mathematically only. Now, that raises an interesting philosophical question as to whether there's actually any net gain by using these inventive theories during a period when we would otherwise have no theories at all to account for some important physical phenomena. Actually, we don't need them. We could equally well use the mathematical relations that we have without any theoretical explanation. In any event, the fact that needs to be recognized at the moment is that we have again arrived at the kind of a situation that existed in the Middle Ages. The present-day inventive theories have accumulated too many epicycles. And at the same time, inductive theory has caught up with observation and experiment, so that as we enter the 21st century shortly, we are in a position to go back from the inventive theory to a solidly based inductive theory again. Now, the imminence of such a change could be deduced simply from an examination of the times involved in the cycle of reversals that I've been talking about. The first inductive theories lasted for thousands of years before they were overthrown by the Greek inventive science. Now that, the first of the inventive sciences, endured for 2,500 years before it met its fate at the hands of Newtonian inductive science. The accelerating pace of science is shown by the fact that in spite of its greatly superior character, the science that's normally associated with the name of Newton only lasted for 400 years before it in turn succumbed to the second inventive science. Now, if we consider the same rate of acceleration, we can see that since another 100 years have passed, that we are about due for another reversal will take us back into an inductive theory. But we don't have to depend entirely on inferences of that kind, because there's plenty of direct evidence to show that we are again in the same kind of a situation in which Greek science found itself during the Middle Ages. In the first place, the accumulation of epicycles has reached the point of absurdity in a great many cases. The quantum theories, for instance, have a long history of one ad hoc modification, interpretation after another, until it's very questionable now if the theory is even intelligible. In fact, Richard Feynman, who I've already quoted a couple of times, says it isn't. Feynman says this: I think I can safely say that nobody understands quantum mechanics. The situation in the field of atomic structure is much the same. The favorite pastime there these days is inventing properties for the elusive particles called quarks. Now, nobody has seen or otherwise observed a quark, or anything that could be a quark. In fact, the most urgent problem for the theorists right now is to invent some theory by which it can be said that the quarks are inherently unobservable. But nevertheless, we are told just what kind of quarks can exist and what their properties are. Such interesting properties as color, charm, and so on. In order to fit this situation into the proper perspective, let's bear in mind that not only are the quarks themselves unobservable, but the particles that are supposed to be constructed out of quarks have never been observed either. Now, it's true that those particles are given some familiar names, such as electron, for instance. But the hypothetical electron, constituent of the atom, has a totally different set of properties from the observed electron, and there's actually no adequate justification for calling them by the same name. The same is true of the other hypothetical constituents. The hypothetical neutron constituent of the atom, for instance, has to be stable, whereas the observed neutron is very much unstable. The truth is that there is no definite evidence that the atom is constructed of particles at all. Now that may seem to be rank heresy, but a great many of our foremost scientists have said the same thing in different words. For instance, here's Erwin Schrödinger. Once we have become aware of this state of affairs, the epistemological question, do the electrons really exist in these orbits within the atom, is to be answered with a decisive no, unless we prefer to say that the putting of the question itself has absolutely no meaning. Here we have a good example of the difference between induction and invention in the construction of the theory. And since I'm making this my principal point, I want to elaborate on it a little. Such men as Newton and Einstein were very much aware of that difference. Newton insisted time and time again that he did not resort to invention. Einstein, on the contrary, criticized Newton for trying to get his theories inductively. And I'm afraid that a great many people do not recognize the difference because they both start in the same way. They both start with a hypothesis. That's the only way we're going to arrive at something more general than what we already have. We have to start with a hypothesis. But the Newtons look upon that hypothesis as something to be tested. They test the hypothesis, and if it doesn't fit the facts, they throw it out and try a new hypothesis, or at least a greatly modified hypothesis. They test that, and if that doesn't work, they try another one. On the other hand, the Einsteins take that hypothesis and test it, and if it doesn't work, they invent something to make it work. And if that doesn't work quite right, they invent something to help the first invention make it work. Well, you may think I'm being funny on this, but read Einstein himself, and he tells you exactly that's the same thing in different words. As he said, it has to be pure invention. But that's the difference between induction and invention. In the one case, it's hypothesis, test, discard. Hypothesis, test, discard, until we finally don't have to discard. In the other case, it's hypothesis, test, invent. Test, invent, until we get something we don't have to invent anymore. When it was first discovered that atoms disintegrate under certain appropriate conditions and emit particles in so doing, it was a very natural hypothesis that the atoms were constructed of such particles. But now that we have found out that those particles do not have the properties that are necessary in order to be constituents of atoms, we have a totally different situation. We no longer have any justification for inventing something that we can find no trace of. But the general opinion still stands that these atoms must be constructed of particles. And present-day theories are obsessed with the idea that they have to keep on dividing and subdividing until they get to something that they can call an elementary particle. In fact, the whole situation in with the physical particles is beginning to resemble that status of the fleas in that popular little verse that maybe most of you remember. It goes something like this: big fleas have little fleas upon their backs to bite them. The little fleas still smaller fleas, and so on ad infinitum. The impetus for this frantic search for an elementary particle of matter comes from the present day concept of the nature of the universe, which sees it as one in which the basic entities are elementary particles of matter existing in a framework provided by space and time. But the modern discovery that matter can be converted into non-matter and vice versa has completely destroyed that concept. It's now obvious that matter cannot be the basic constituent, that there must be some common denominator underlying both matter and non-matter. And since that is the situation, there must be some level below which matter does not exist, and that which exists is this common denominator, whatever it is. It's that error that has caused astronomy to far exceed science fiction, with all of its collapsed stars, its neutron stars, its black holes, its white holes, its wormholes. No, I'm not making that up. That's in the literature. I noticed last week that quark stars have been added to the list. It's that conceptual error that's brought astronomy to that pretty pass, we might say. Our reciprocal system enables explaining all these things without those fantastic ideas. It brings the physics of the far out regions down to the same simple and logical relationships that exist in the more familiar regions of our everyday experience. Now, I'll have to admit that maybe that isn't what you want. Maybe we're merely regarded as heartless destroyers of pleasant illusions and entertaining ideas. So be it. There's one happy thought I want to leave my associates with, and that is that even though we're doing the same thing that our predecessors did in the Middle Ages, we're challenging a thoroughly entrenched and established system of inventive thought